You know the drill? Critical piece of deck machinery on a cargo ship, maybe? Or a huge crane on a construction site. It's the backbone of your operation.
Right. Absolutely vital stuff.
But then, something seemingly small happens. The mounting holes get worn out, maybe oval-shaped, and suddenly that vital equipment, it's unsafe.
Yeah, that oval shape is a classic sign of wear. Big problem.
And traditionally, this is where, well, the nightmare begins. We're talking weeks, sometimes months of crippling downtime. The just astronomical cost of bringing in massive cranes, dismantling the machine, hauling it off-site for repair, then doing it all again in reverse.
The logistics alone are staggering.
Exactly. I've seen projects where this exact issue just stopped everything. The cost, through the roof, stratospheric.
It's a scenario nobody wants to face.
Okay, so let's unpack this a bit. What if you could just flip that script?
How do you mean?
What if instead of moving that whole massive piece of equipment, what if you could bring the precision of a machine shop directly to it, right where it sits?
Okay. Now you're talking. And that's precisely what we're diving into today.
Good.
We're exploring how this revolutionary tool, the portable boring machine, is turning these industrial nightmares into, well, manageable on-site fixes.
Okay.
What's really exciting here is how this tech is shaking up the way industries approach these large-scale repairs. It's redefining both efficiency and precision right there in the field.
Redefining efficiency and precision. That's a pretty strong claim.
It is, but I think it holds up.
And to really get that, we first need to appreciate the sheer scale of the challenge. You know, those worn mounting holes.
Yeah.
The traditional way of fixing them. It wasn't just an inconvenience, was it?
Oh, absolutely not. It's an operational collapse waiting to happen.
Yeah.
When we talk about the total cost of repair, it's so much more than just the workshop bill, you know?
Right. Tell me more about that.
Well, you have to factor in every single step. The labor, the specialized gear for disassembly.
Right. Getting it apart safely.
Exactly. Then, the huge expense of hiring heavy cranes, sometimes multiple cranes, the cost of transporting these, colossal components to a workshop and back again.
Which might be hundreds of miles away.
Could be. And then, crucially, the cost of the downtime itself. When your whole operation grinds to a halt because one machine is out, that's where the financial pain really bites deep.
It just cascades, doesn't it?
Absolutely. It impacts schedules, contracts, the bottom line, profitability, everything.
Okay, so the problem is clear. Huge costs, huge delays.
Right.
So this solution, the portable boring machine, what exactly is it?
Well, it's pretty much what it sounds like, but the engineering is quite clever.
It's like a mobile machine shop, essentially, moving the tool instead of the mountain.
That's a great way to put it. A portable boring machine, or sometimes called a line borer, it's designed to clamp directly onto the large workpiece itself.
Right onto the broken part.
Right onto, or adjacent to, the area that needs repair. It then uses a rotating boring bar fitted with cutting tools to accurately machine or repair those holes right there, on site. And the design itself is quite something. It's usually modular, built in sections.
So it's manageable. Like people can actually carry it.
Yeah, light enough for 1 or 2 technicians to set it up, but don't let the portability fool you. It's robust. Powerful enough for heavy-duty cutting.
Okay, interesting.
And its mounting versatility is really key, too. They use these advanced sealed lubrication systems.
Meaning?
Meaning they can operate horizontally, vertically, even upside down. It adapts to pretty much any orientation you need.
Wow, okay.
And for that crucial precision we talked about, they rely on heavy-duty, zero-clearance spindle bearings. These are absolutely critical.
Why is that?
They ensure smooth operation, a flawless finish. They basically eliminate the vibration that could mess up the accuracy, especially under tough conditions.
That makes sense. That sounds like some really smart engineering.
Yeah.
So, okay, capabilities. What kind of size are we talking? What diameters can these things actually handle?
Well, they're built for industrial demands, so the range is pretty wide. Typically, you'll see them boring diameters from, say, 30 millimeters, maybe 1.25 inches or so.
Right.
All the way up to 300 millimeters, which is what, nearly 12 inches? And sometimes even bigger for specialized jobs.
That covers a lot of ground and power. Are they electric, hydraulic?
All of the above, really. You find electric, hydraulic, or pneumatic versions. The key thing is they're engineered for constant torque.
Which gives the operator
precise control, really fine control over the cutting speed and feed rate.
And how much material can they actually remove? Are they just skimming, or can they take a real bite?
Oh, they can take a bite. In terms of raw cutting force, they're often powerful enough for a single side feed rate of over 3 millimeters per pass.
So quite aggressive if needed.
Definitely. They can remove material efficiently. And another thing is their versatility. You can often fit them with a facing head.
For doing what?
Machining the end faces of the holes, making sure everything is perfectly flat and square. Or sometimes they even integrate portable welding systems. Ah, so you can add material before you bore it, if it's really worn down.
Exactly. Build it up, then machine it back to the perfect dimension. And of course, the whole point is they're lightweight, compact, easy to transport, fast to set up right where you need them.
Okay, you've painted a really clear picture of the what and the how. But let's dig into the why a bit more. Beyond just, fixing a hole, what are the biggest impacts, the real bottom line benefits of doing this on site?
Yeah, this is where it gets really interesting, I think. The insight here is that this tech doesn't just fix a problem, it fundamentally changes the economics of heavy equipment maintenance.
How so?
The biggest advantages are, number one, drastically reduced downtime, and number two, enormous cost savings.
Okay, let's break that down. Downtime first.
Right. By completely cutting out the need for disassembly, offsite transport, reassembly, you can literally slash repair times.
Yeah.
Sometimes by up to 90%.
90%. That's huge.
It is huge. Think about it. A repair that might have sidelined equipment for weeks, maybe even months.
Yeah. Can often be done in just hours, or maybe a couple of days. Right there, in the field.
So the asset gets back to work almost immediately.
Exactly. Generating revenue instead of just sitting there costing money.
That point about changing the economics, it reminds me of something I heard. A case where a 2-week repair job was squeezed into a single day using this tech.
I believe it. I've seen similar things.
That's not just saving money, that's a massive competitive edge, isn't it?
Absolutely. And that ties into the cost savings. Beyond just the time.
The direct costs.
Yeah. You eliminate a huge chunk of the repair budget. No massive transport fees. No need for those big, expensive crane rentals for days on end.
And the labor, too, I guess. Fewer hours needed for taking it apart and putting it back together.
Significantly fewer labor hours. Think about the planning, the rigging crews, securing the site for those complex lifts. All that goes away or is drastically reduced. The whole repair becomes focused, fast, financially smarter.
Makes sense.
And there's another angle, too. Flexibility and safety. Because the solution comes to the problem wherever that is.
On a ship, down a mine, remote site.
Exactly. Incredible flexibility. And it enhances safety. You're reducing the risks that always come with lifting and moving massive, heavy components.
That's a really good point. Which brings up maybe an obvious question, but an important one. Precision.
Yes.
When you hear portable, you automatically think, is it as good, is it as accurate as doing it in a dedicated workshop?
Yeah.
Especially out in the field, maybe in, less than ideal conditions.
That's a fair question. And it's probably the most common one people ask. Is portable less precise?
Yeah.
And the answer with modern high-quality machines is definitively no. They can achieve exceptional results, truly rivaling stationary workshop equipment.
Okay, how? What makes that possible?
It comes down to several key things. First, the setup has to be absolutely rigid.
How do they manage that?
The machine frame is securely mounted, often bolted, sometimes even welded temporarily right onto the workpiece itself. That creates a really solid foundation, no wiggle room.
Okay, solid mounting. What else?
Second, alignment. The operators use incredibly precise alignment tools. Dial indicators, or maybe even laser alignment systems.
And get the boring bar perfectly centered.
Perfectly centered. We're talking accuracy often within 1/100th of a millimeter.
Wow, it's tiny.
Duh.
Less than a human hair.
Pretty much. And finally, it goes back to the machine's construction. Those heavy-duty bearings we mentioned, the constant torque drive, they ensure a smooth cut, no chatter.
Cheddar being.
Vibration during the cut, which ruins the surface finish and accuracy. So no chatter means a clean cut.
So the end result is a hole that's basically as good as new.
Or even better sometimes. You can consistently meet or exceed original specs, tolerances. You can expect things like H7 class fits, which is a standard engineering tolerance, very tight, often used for press-fitting bearings perfectly. And the surface finish, you can achieve better than RAW 1.6.
RAW 1.6, meaning very smooth.
Very smooth, like almost mirror smooth, more than smooth enough for any critical mounting job.
Cool.
So yeah, precision is absolutely achievable in the field.
That's impressive. Dispels that myth pretty effectively.
Yeah.
So, okay, who's actually using this? Who's benefiting? It sounds like it's way beyond just ships and cranes.
Oh, absolutely. It's really a foundational technology across heavy industry. You see it everywhere.
Like where specifically? Who are these unseen heroes keeping things running?
Well, construction and mining are huge users, probably the most common application area.
For what kind of repairs?
Think about pivot pinholes on excavator arms, loader buckets, bulldozer frames. These things take incredible stress, and those pinholes wear out, often into that oval shape we mentioned.
Right.
So a portable boring machine, often paired with a portable bore welder first to add material.
Rebuild the worn area.
Exactly. Then they rebore the hole to perfect roundness, right
Yeah.
there on the job site. It literally extends the life of equipment that costs millions.
Makes sense. Where else?
Shipbuilding and maritime, definitely. We talked about deck machinery mounts, but also rudder systems, stern tubes way down below the waterline. It allows critical repairs during those really short dry docking windows, saves enormous amounts of time and money.
Keeps the ship sailing.
Precisely. Then there's power generation. Think about massive turbines, generators, incredibly difficult and costly to move.
You can't just pop a turbine out.
Not easily. So a portable boring machine can repair, say, bolt holes on a huge turbine casing, or maybe bearing seats on a wind turbine gearbox without needing that massive disassembly that could take months.
Wow. Okay. And the other big ones?
Yeah. Petrochemical and steel industries. Think about plants with continuous production lines.
Where any shutdown is disastrous financially.
Exactly. So they use these machines to repair things like rolling mill housings, large compressor cylinders, often in really tight, confined spaces. It allows for rapid repairs during those very short planned maintenance windows, keeps the production line moving.
So it sounds like almost any industry with big, heavy, hard-working machinery relies on this.
Pretty much. If it's big, works hard, and has critical holes that wear out, this technology is likely essential for keeping it maintained efficiently.
Okay. So let's try and bring this all together then. We've seen how these portable boring machines are, well, genuinely transformative. It's not just hype.
No, I don't think it is.
They bring that workshop-level accuracy right to the job site, drastically cutting repair times, slashing costs for huge, often immovable equipment across, well, countless industries.
It's a very pragmatic but also really ingenious solution.
Yeah, it keeps the wheels of heavy industry turning, keeps our infrastructure running smoothly, efficiently.
It really does. And, thinking about it, it raises a bigger question, perhaps.
Oh, yeah. What's that?
Well, when you consider all this vast, complex infrastructure that our modern world depends on.
The ships, the mines, the power plants.
Exactly. How many other unseen hero technologies like this portable boring machine are quietly working away behind the scenes?
Good question.
Preventing chaos, fixing problems, ensuring our world keeps turning, technologies we might never even know about.
Yeah, things we just take for granted.
It really makes you appreciate the constant innovation, the ingenuity that goes into just maintaining everything that keeps our society functioning. It's quite remarkable when you stop to think about it.